Hello, my name is Janos and I will talk about benchmark HD mapping Grand Truth. So we will prepare Grand Truth for our benchmark. Okay, let's click this one and let's see what we can do. Hint, we go to our favorite branch and let's check what we have. Okay, with this instruction you will prepare Grand Truth trajectory. Okay, so step 1, download reference Grand Truth terrestrial laser scanning data from following links. Then you create this folder. So we open new terminal. We make folder, we go to this folder, and then we have to copy this file from downloads. So let's find downloads. I have those two files, so yes, I will copy it. Okay. Okay, and ls. Okay, so it is copied. We have this data. And what we can do now? Convert this file to last file with following command. On this following, I have to fix it. Okay, I will fix it just after this movie. Okay, so we go. We have to go to the. We can find this command pcd to last exe in our HD mapping folder with executables. So let's find this one. Let's find this folder. So once you have this HD mapping, it is in our case projects GitHub HD mapping build binaries. Once we have this one, this folder, and once we open a terminal here, then we have this command pc to las. Oh, I have to change this exit is on the Windows, but don't worry about it. So we have this pc to las pcd to las, and we have this paste. We convert this one. Okay, so it is converted. We can close it. So we have also las file. Okay, and now we can go to the step 2. Alternatively, you can use Cloud Compare, so you can watch this movie. I don't know if it is working. Sometimes in Cloud Compare we have some issues. Oh, it's another mistake, cloudy. Okay, I have to change a lot. I'm so sorry for that. Okay, so step 2, download the dataset back. It is downloaded. So if it is downloaded, so we make a directory, and then we go there, and then finally we copy this file here. So we have to put here our folder with downloads. Give me a second. Okay, so we copy data. Now it's a huge file, so we have to wait a little. What we have in our folders, so what we have so far is our benchmark data, Grand Truth. We have those two folders, and this one, it is copying. It is 50 gigabytes, so it's a lot. So what we are going to do in this movie, we are going to use data from bunker dataset, and we will try to make a trajectory ground truth trajectory. So what we do now, we have to we copy it. So step 3, it is we make directory, and then we go there, then we clone Monday to back. Oh, it already exists, so I will just remove it to show you that everything works proper. So Monday to back, home, our benchmark, Monday to back, I will remove it, I will clone it recursively, and then we go there, and then we paste, and we build the Docker. In step 5, we create last folder with our data in HD mapping format. So we go there, we change some parameters for the files, and finally we convert our data. So you can see that our data, ground truth data, they are exporting to this folder. So what we have Faro last file, we have growing ground truth trajectory in HD mapping format, and we have also ROSBAG for ROS lovers. Okay, so let's go back. Step 6 will be about preparing ground truth data using LiDAR Odometry step 1 and follow procedure in this movie that we are doing at this moment. So let's start with this procedure. It is not automatic, so big apology for those who likes full automation. This is semi-automatic. So we go to our project, and give me a second, GitHub HD mapping, and we have LiDAR Odometry step 1, and we have presets. We will take a generic, we choose a generic parameters for this purpose. Then we go to the settings, and we go far to load last file as a reference point cloud for initial alignment, and we try to find it somehow in our data that we prepared for ground truth. So it is still as Faro, and this is last file. So we open last file, this one, and let's wait a little. Okay, this is our ground truth. So now we're supposed to load data. So we load data, and we load our HD mapping format data. So they are now indexing, and they appeared here. So what we have to do, we have to use this semi-automatic alignment based on Gizmo. So we show Gizmo, and this is semi-automatic tool, so you have to just simply find the initial transformation manually. Obviously speaking, this is not accurate, but you have also align to reference button that using normal distributions transform, it can align perfectly to the ground truth. So you can see you have very nice initial point, maybe 1 centimeter error or maybe half, I don't know, we will check later on. And then once you have it, you can start calculations. So compute all and wait a moment. So you have these calculations, and during this time you can prepare in Cloud Compare visualization. So if you have Cloud Compare, and if you load Grand Truth LAS file, and if you put 0, 0, 0 as a translation, then you load it, and then in HD Mapping Grand Truth you have preview, and you can see in this folder data are stored every time it calculates 100 points. So I will find it and I will show you. So these are all calculations. So you can see 700 from 3000, and every 100 you have some preview, and this preview you can put to Cloud Compare, and this preview contains 1% of the points, so it is only for the preview. I will show you later on how it looks like in reality, in full resolution, sorry. Okay, it is calculating. It is already 30% of the data set, so we have plenty of. Okay, so if you zoom your Cloud Compare, you can have once you zoom your Cloud Compare, you can have some imagination how your data is aligned to Grand Truth. I think during the calculation on full capacity, we are struggling with computer power, so it cannot so much show you everything. Okay, we load more preview data. I hope my computer will not crash. Still we have 30% of the calculation, so let's hope everything is okay. Almost done. Okay, let's zoom and let's observe. So shortly speaking, I can see that there is not so much difference between Grand Truth and our calculations. So you can see that our data is aligned to Grand Truth. It is very promising. Okay, so what we have already 2700 nodes optimized from 3200. Each node corresponds to 200 Hz of IMU data, so it is like full resolution of the calculation. So each data from IMU is optimized. That is why it is so accurate, so precise, and so robust. I hope I will publish this soon, so you will know better about the algorithm. Unfortunately, it is still under the review after rejection, so I hope I responded to reviewers very well. I hope you will have more info soon. Okay, but by the way, we have almost finished, and what we have, we have our trajectory, that it is our Grand Truth trajectory, and this trajectory is based on our LiDAR Inertial Odometry from HD Mapping that can be also facilitated with external Grand Truth point cloud, and now I will show you how it works. So why it is not showing me? Give me a second. So our ground truth data supposed to be okay, I have to save it. So save results. Press this button for saving resulting trajectory and point cloud. So single session can be viewed in step 2. Save. It is saved. It's a very important step to save data. Okay, and the results are saved in LiDAR result 0. Okay, so we can close the program, and we have ground truth trajectory and point cloud. So we have LiDAR result 0, and our session is here. And let's observe. Let's check what it can offer. So we open now step 2. We open this session that we already prepared. This is our session. Okay, this is ground truth session, so we can export point cloud, save all marked scans as global scan, and it will be all PC LAZ, and we will save all marked trajectories as XYZ and quaternion format for further quantitative and qualitative analysis. Trajectory all CSV, and let's check in Cloud Compare. Our trajectory against Cloud Compare. So we will add here some reference data, ground truth reference data. So we have LAS file, and then we have to put 0, 0, 0, yes to all, and then we add ground truth point LAS. Okay, this is our reference point cloud, and these are our data points that we calculated, and we mark them, we change color into green, for example, and trajectory all. This is our XYZ, apply all, and we have everything now we need. So what we have trajectory, maybe I will change the color to the yellow one. And what we have our reference, reference data from TLS. Give me a second. Okay, this is ground truth data, and we have trajectory. So I will show you the quality of this ground truth against our trajectory. So we will make some, let's say, I will make some intersection to give you impression the quality. So you have trajectory, you have ground truth, and you have ground truth data, so you can see that it is aligned to the centimetric level. So you can see the white one is a ground truth, and green one is data from Livox, and you can see that our ground truth procedure is on centimetric, maybe even millimetric level. I can give you some distance between point and, so let's measure the distance. For example, this one to the ground truth 001, so 1 centimeter. So when we can say that it is centimetric accuracy. Thank you for watching this movie about making ground truth trajectory for this particular dataset with our HD mapping software. See you soon in further qualitative and quantitative analysis. Thank you, see you soon.